Hey y'all, welcome back. Today we're looking at the last scenario that we can solve with the law of sines, the angle side side, the infamous ambiguous case. And first what we're doing here on the homework is we're just going to determine how many possible triangles there are. And as we talked about in the lecture, there's either going to be 0, 1, or 2 possible triangles. So we're going to try to figure out how many there potentially are, but we're not actually going to solve it in this first section. It's not going to be until we get to this second section where we actually solve out the triangles and figure out what the missing sides and angles are. So with number 1, we're just going to simply figure out whether or not there's 0, 1, or 2 triangles. So to do that for all of these, we need to calculate the height of the triangle. And to do that, so let me just make a little note here, that the height is equal to the adjacent side, okay, times the sine of the given angle. Okay? So when I say the adjacent side, what I mean is not the side opposite of it. So like in this first example, since they're given angle A, the side that we'll use is side B. So we're not going to use side A. We'll compare side A to the height, but we don't need that to actually calculate the height. So let's start by actually calculating what the height is. So the height is going to be, in this case, the adjacent side, which is 5 times the sine of 36 degrees all right, and that is going to equal, I have no idea. Let's put it in our calculator and find out. Okay, so we've got, oh wow, what's going on with my calculator here? There we go. Okay, so yeah, so our calculator here, we've got 5 times the sine of 36. Before I hit enter here, I'm going to make sure that I'm in degrees, and I'm not, so I need to go ahead and change this from radians to degrees since the angle measure was given to me in degrees. So I'll change that to degrees, exit out of there. And then, okay, so we get about 2.3, or 2.93. 2.938 rounds up to 9. And really all we care about is whether or not this side that's opposite is bigger or smaller, and then depending on what happens, we'll make our determination. So let me go ahead and just write out the 4 cases here so that I don't have to keep referring back to it. But if A equals the height, or if I'll say the opposite side, because it's not always going to be A. Looks like it might always be A in this case, but it's not necessarily going to be A. We could have different letters. So we'll just say the opposite side, which if the angle's A, the side would be A. If that is equal to the height, then we have one triangle. If the opposite side is smaller than the height, like it's too short, then there is 0 triangles. If the opposite side is greater than the height, and the opposite side is greater than the adjacent side, then we'll have one triangle. And the one case where we'll get 2 triangles is if the opposite side is not only greater than the height, but also smaller than the opposite side, or adjacent side. So I'll just kind of leave this up here because this is going to be how we determine, how many triangles there are. Just make a little cheat sheet here. Okay, so going back to here, we're going to see, okay, so the opposite side is going to be this A. So we're going to compare the A value to the height. And we see that the A value is greater than the height. So then when the A value is greater than the height, then we're either going to have one or two triangles. And then to determine whether it's one or two triangles, we'll compare this to the opposite side, the adjacent side, which is 5. So we'll say, okay, so the opposite side is greater than the height, and the opposite side is greater than the adjacent side, so there's going to be one triangle here. Okay, if we want to basically write out the justification for this in a little bit cleaner way, we can say that since A is greater than the height, and A is greater than the side B, there is one triangle. Okay. I'll just, oops. Well, I guess I'll leave that in there. Okay. Being a little wishy-washy here with how I want to word this. Okay, so there we go. So let's look at the next slide, the next one. So we're going to do basically the same thing. We're going to calculate the height, and then we're going to compare this opposite side to the height, and if necessary, to the other side. All right, so the height in this case is going to be 16 times the sine of 110. And so we'll type that in. 16 times the sine of 110, and we get about 15. All right, so we're going to compare these, and we can see that this is clearly bigger, okay? The A is bigger than the H, okay? And then we're going to compare it to B. A is bigger than B as well, so we get one triangle there. So both of these will only have one triangle. All right, for number 3, we are going to do the same thing. We're basically going to do the same thing for all these in this section, where we calculate the height, and we do some comparisons, and just kind of go from there. So the height here is going to be equal to 10 times the sine of 60 degrees, and that equals, I don't know. Let's find out. Actually, this one I should know, because 60 is one of our common angles. So sine of 60, from your perspective, that would be from here, right? So 60 is about there. Sine of 60 should be root 3 over 2. So root 3 over 2 times 10 should be 5 root 3. Yeah, but it's really going to be more useful to us as a decimal anyway, so I'm just going to keep plugging it in. So we get about 8.66. Okay, so A value is bigger, right? A value is bigger than the height, but in this case, the A value is smaller than the other side. So in that case, where the A value ends up being smaller than the other side, we end up with two triangles. Okay. Yeah, that's pretty much it. You know, with all of these, we're just making those two comparisons. We're going to compare the opposite side to the height, and then if we need to, compare it to the other side. But in some cases, we don't even need to do that, because if this is going to be smaller than the height, then we won't have a solution anyway. All right, we don't really need all these extra circles, do we? Okay, so let's look at the next one. We've got 50 times the sine of 85, which is, let's see here, 50 times the sine of 85 is 49.809 would round up, so 810. Okay, so now look at this. Our opposite side is smaller than the height. So that's going to be this case right here. We don't even have to check it against the other side. We can just say since that a value is smaller than the height, then we get 0 triangles. In other words, there's no possible triangle for this to happen. Just to kind of give you a little visual why that is, here's B, here's C down here, and then A is 35, but the height is 49. So if this is 49, and that's the height, the other side out here is only 35. So it's just not long enough to hit this other side. So, this could like kind of swing back and forth, but the very shortest it could possibly be is the height. So if it's shorter than that, you just can't make a triangle. Okay, so there we go. Let's move on to number 5. And I guess I can kind of drag this down as we need it. We'll need this for pretty much all the problems. Okay, so I'll just kind of stick it right here. On this one, we've got, let's go ahead and copy this. The height is equal to, come on. Ugh. That didn't copy very well. Here we go. Okay, so the height is going to be, let's see here, what we got? 10 times the sine of 100 degrees. And we get 9.848. Okay, so A is bigger than the H, okay, so that's good. And it's also bigger than not B, we've got C here. Yeah, we had C up here too. Did I make any other mistakes here? No, B, B, okay. So, yeah, since it's also bigger than the adjacent side, we're going to say that this is going to be this case right here, okay? Oops. It's always something. Here, I'll pull it down here. So yeah, so we know that the opposite side, which is the A, is greater than the height. We also know that the opposite side is greater than the adjacent side, because the adjacent side is only 10. And so there's going to be one triangle. All right, now this last one. Again, we're not trying to solve the triangle yet. We'll do that on the next section. Right now we're just kind of practicing, trying to figure out how many triangles are going to be. Because it's important with this case to know, hey, is there going to be multiple triangles that I got to find or not? So anyway, let's see here. So in this case, the height is going to be 12.8 times the sine of 58. We'll put that in our calculator. All right, we get 10.855. All right, so we have our opposite side is greater than the height. Okay, so it's either going to be this one or this one. And then, so let's compare it to the other one. We say it's smaller than the B value, or that adjacent side. So that means we're going to get two triangles. So since A is less than B, we do get two triangles. All right, now we'll have to go through that process on all of these other problems as well. This is really just the first part of it so that you know how many triangles you're trying to solve for. So now that we've kind of practiced that a little bit, let's get into one of these actual problems. There's not really that many because some of the, especially if you get two solutions here, they do tend to take a bit of room and a bit of work here to get there. So let's look at the first one. All right, so now we're doing the real deal. We're actually trying to solve this. So before we actually solve this triangle, we need to determine how many triangles there actually are. So in order to do that, we need to do a little investigating here like we did above. And so we're just going to figure out how many triangles we are expecting. Okay, so the height is going to be equal to, just like how we calculated in the last section, in this case 10 times the sine of 60. Did we already do that one? It looks like we did. Okay, that's okay. We didn't actually solve the whole triangle, so I just recognized the 60 degrees. So I'm pretty sure we already calculated that, didn't we? 10 sine 60 should be up here somewhere. Yeah, there we go. So this is going to be 8.66. All right, there we go. 8.660. And so since this opposite side, A, is greater than the height, and A is smaller than B, we can say that there is two triangles. Okay? When that opposite side is greater than the height and it's less than the adjacent side, we get two triangles here. In fact, why don't we just bring this down here, because we're going to need to keep referring back to this. Oh, it's not going to let me take it past the first page. Oh, no. All right, that's okay. We'll just scroll back up when we need it. Okay, so let's try to sketch out, see what's going on here. So anytime you've got a situation like this, we go ahead and draw first the bottom side. There we go. And then we want to make a 60-degree angle here, and with Cami I can get pretty accurate with that. 60 degrees, it doesn't have to be perfect, but it's going to be something like there. Okay, and then the other side is going to be one of two things. Okay, it's going to be 9, but it can either be 9 going this way, or it could be 9 going that way. Right? So we need to solve both of these triangles, and what I'll do is like split this up so you can more easily see where the two triangles are. All right, so what I'm going to do here is just copy and paste this twice so you can kind of see a little easier where the solutions are. So one triangle I might have is this one. Okay. And the other triangle I might have is this one. All right. So this bigger one, just to be clear, is like this outer triangle. So this outer side is going to be the same in both cases. Okay. This is our 60-degree angle measure right here. Right here, I'll just type that, make it a little easier to read. And this is going to be 60 in both cases. So 60 here, 60 here, 60 here. It's that bottom left corner, that angle right there, 60 degrees. And then the side opposite is 9, and so that could be this one, it could be this one. Okay, so in other words, like, it's one of these two. Okay, it could be either one. And the B is 10. So this side is 10 in every case. Okay, so it's really just this opposite side that could be kind of leaning down at the left or down to the right, and there's enough room either way for it to be 9. Okay, so we're going to solve these separately. We're going to end up with a total of 2 solutions here, where we need to find angle B, which is going to be here or here. We can call these like B1 and B2. I'll just call this B1 and this B2. And then we've got C, C1 and C2. And we've got the C side. So I'll call those little c1, little c2. So I'm going to make a little answer key here, so I just can keep track of everything that I need to find. I need to find B1, angle B1. I need to find angle C1. And I need to find side C1. And then I'm also going to need to find those solutions for the second one. It's just, I'll just call them B2, C2, B2 and C2. All right, for our two different solutions here. And it doesn't really matter which one you call 1 and 2. You got to just pick one, and so I just went with this. Okay, so we're kind of ready to start solving here. Now, the first thing we'll solve for is, I'll just make a little box here so I can know this is where my answer is going to go. Let's try to solve for the missing side, or the missing B angle, and we'll use the law of sines to do that. So let's go ahead and set up a law of sines using this pair that we have, the A's rather, the 60 degrees and the 9, and figure out, okay, which one is that going to tell us? So we've got the opposite side, which is 9, over the sine of 60 degrees equals, and let's see, is this going to be B1 or B2? We'll find out pretty quickly. If it's obtuse, it's going to be this one. If it's acute, it'll be this one. So we've got the side B is 10 divided by the sine of angle B. And whether it's 1 or 2, again, not 100% sure yet, but we'll find out pretty quickly. So we need to solve for B here. We're going to cross multiply, so we get 10 times the sine of 60 equals 9 times the sine of B. And so we'll divide both sides by 9. And so we'll get sine of B equals 10 sine of 60 divided by 9. So to isolate B here, we need to take the inverse sine of both sides. So we get the inverse sine of all this. And this is going to be what angle B is. So this is going to be something we throw in the calculator. So let's get out the old calculator again. Scroll up so you can see it. We got the inverse sine of, set up a fraction here, 10 times the sine of 60 over 9. All right, so we get about 74 degrees. And that's going to have to be this one over here. Okay, so just, so you know, you're going to most likely get the one that's going to be the acute angle. But really, you just want to make sure when you type it in that is what you get. So yeah, let's see, we got 74 degrees, roughly. I wonder if I could just copy this over. Let's see. Nope, didn't like that. I'll just do it kind of a very hacky way here. Here we go. Okay, so yeah, we get approximately 64 degrees. There we go. Okay, so we can use that to find B1. Now this is kind of the trick here, is that these two angle measures over here are going to, like this one, since this is creating like a little isosceles triangle in here, that's not this triangle over here, but this one that I'm kind of tracing out right here is isosceles because you have the 9 and the 9, which means these two angles have to be the same. And since these two angles are the same, we can say that the sum of angle B2 and angle B1 have to add up to 180. So if I find the difference between the B2 here and 180, if I do 180 minus the B2, which is what we just got, I get about 106 degrees. So we'll say that this is approximately 106 degrees. All right, so we got both B values, okay? It's good to have these diagrams to really keep it straight what's going on here. So we got this angle measure. So now we can use this angle measure to find the two different C values, because remember that all the interior angles of a triangle have to add up to 180. So now we have two of the three, so we can find this other one. So we'll say that 180 minus that 74 minus the 60, the original 60 that we knew, that'll give us about 46 degrees. We'll calculate C1 in kind of the same way here. It's not going to be 46, but we'll do 180 minus that 106 number that we had, minus 60. And so this one should be 14.2, so about 14 degrees. And then the last thing to do is find this missing C value, this missing side. And to get that missing side, we need to use the law of sines. Okay, so we're actually going to complete this problem, we actually have 3 instances of the law of sines. How about that? Like, that's kind of a lot. We use the law of sines once to get that original B angle. And then we are going to use it again to find this missing C value. So, just to kind of save me a little bit of typing here, I'm going to copy this twice, one for each C value. Okay, so we have 9 over sine 60. I'm not going to change anything there. But here, I'm going to say C1. Oops, not F. What's going on there? C1, there we go. Over the sine of 14 degrees. And over here, I want to find C2. And that'll be 46 degrees. All right, so to solve for C1 and C2, we're going to cross multiply and divide, just like we did in the last lesson. So we're going to multiply 9 times sine of 14, divide by sine 60. So that C1 is going to equal 9 times the sine of 14 degrees. Divided by the sine of 60 degrees. All right, and we will solve for the other missing side the same way, except we'll just have 9 times the sine of 46. The other stuff will be the same. Okay, so C1 then is going to equal whatever I get from the calculator of that, and then we'll have a value for C2 as well. Okay, and we'll put those here and here. Okay, so let's go ahead and start typing that stuff in, yeah? You can see these problems definitely take a while. Real pain in the angle side, if you know what I mean. I guess these are going to be approximates too. Might as well just get ready to type that in. Oops. I don't know why it does that. All right, so now let's go to the calculator and start typing away. So we've got 9, oh, not 3, 9 times this, nope, not 39 either. Come on, Mr. Schuler, you got this. 9 times the sine of 14. And really, you know, if you want to be a little bit more accurate here, let's not use 14. Let's use like what we actually got. Instead of 14, we got this 14.2. You'll just be a little bit more accurate there. Over the sine of 60. So you get approximately 2.551, I guess is what we'll say here, 2.551. And to get the next one, oops, I guess I don't want to put that there, 2.51, there we go. And then to get C2, we're going to type in essentially the same thing again, except instead of this 14 angle measure, we've got the 46. And just like with this one, 46 is fine, but your rounding is going to be a little off if you use the rounded version. So let's just get as close as we can here and use this version right here. Okay, so we'll type that in, and we get approximately 7.449. All right, so we did it. We've got both sets of solutions. Just to kind of walk through. First thing we did here was figure out how many triangles there were, okay? Then we did a sketch of the triangles. Once we kind of got our bearings straight here on what we needed and what everything looked like, we found the missing angle measures. This is the third thing we did. And then the last thing we did was use law of sines to find the missing sides. So there you go. Well, 1, 2, 3, 4-step process. So yeah, we'll do that again down here. We have we've got 2 more problems like that, and then we've got these little logic questions down here that we'll get to. Okay, well let's do number 8. All right, so for number 8, I'm not going to copy the whole thing, but I'm just going to copy like one step at a time. All right, so let's see what's going on here. The height here is going to be 8 times the sine of 48. A lot of calculator action going on today. 5.945. Okay, now since our opposite side is greater than the height and the opposite side is smaller than the adjacent side, then we're going to have 2 triangles. Okay, you can kind of expect, since that's kind of what we're focusing on today, that we're probably going to get 2 triangles on most, if not all of these. It'll be good practice. Okay, so let's see what's going on here with our diagrams. I'm actually going to use the same diagram I had up here. The only difference here is like how I'm going to label the angles and the sides, because here they're given us C instead of B, which is not a big deal. We just are going to call the other side C. And so that way we can kind of stay consistent about how we draw our diagrams and all that stuff. So let's go ahead and erase these numbers from the last one. Oops. All right, so this angle down here is actually 48 this time. It's not 60. And that's going to be our angle A. The opposite side is going to be 6. So either this will be 6 or this will be 6, depending on which triangle we're talking about. And then the C side, so we're going to be careful here on how we label this. The C side is 8, so 8 I'm going to put here. Okay, whatever the other side that's given you, I'll put over here. Now, you could rotate the whole triangle if you really want to put C, C down here. Oh wait, no, wait a minute. Oh no, okay, we're good. If you want to put C up here, you can, but it's just easier to put it over here. So, all right, now let's label everything that we need to find. So this is going to be angle C, right? And so with this one, all right, little angle C there. So this is going to be C1 and C2. And then our angle up here will be our B. So we'll call this B1 and B2. And this would be side B. See if I can squeeze in a little B1 here. All right, so there we go. Oh, just want to kind of clean that up. All right, so this is like what they would look like if they were overlaid on top of each other, and this is what they would look like separated out. So now I'm going to create a little answer box for myself just so that I can, I just really want, well, that's okay. I'll just copy that. Delete it later. Okay, so what we need here is none of this. Oh, why is this not erasing? There we go. All right, so in this case, we don't actually want, we do need B1, don't we? We need B1 and C1, but it's just in this case, we'll get the C1 first instead of the B1. And then instead of C being the unknown side, B is. All right, a lot of setup here. It takes a while to kind of get ready to work these out. And then it looks like I lost a side in my hasty erasing, I guess. I'll draw that back in. Okay. So now let's get started. So first things first, we're going to find these two angle measures. And we're going to solve it just like we did this one over here. This will be our next little thing to do here, is to figure out that missing side length, angle measure. It's just that the angle measure here we're going to find is C. And then depending on if it's obtuse or acute, we will determine which angle measure it is. Is it C1 or C2? So the ratio that we know is going to be this 6 over the sine of 48 equals 8 over the sine of C. So cross multiplying will give me 8 times the sine of 48 equals 6 times the sine of angle C. So the sine of angle C will be 8 times the sine of 48 divided by 6. And this is something that we'll just put in the calculator. I'm going to see if I can't just copy what I had before. Is it too far up? Ah, there it is. Okay, so the inverse sine of 8 times the sine of 48 divided by 6. Okay, 82, that is an acute angle, so that's going to be this one over here. What you'll find is that you're pretty much always going to get this bigger one first. Okay, so B2 is going to be 82 degrees, roughly. And then to find the other one, we're going to subtract that from 180. Like we talked about before with the isosceles triangle, we can reason our way through that. And so the other B is going to be about 98 degrees. Now to find the missing C angle, we're going to subtract both of the other two angles that we have inside the, each individual triangle from 180, because we know that these angles have to add up to 180. So we've got 180 minus the 48, the original one we had, minus that 82. And so I get about 50 degrees. For the other triangle, I'm going to have 180 minus 48 minus that approximately 98 number. Oops, left an 8 out. And so I get about 34 degrees. Okay, so now I've got all my angles. The last thing to do here is to find the missing sides, which I will use the Pythagorean theorem. I'm so used to using that all year long. We're going to use the law of sines here to find those missing sides. So for this first case, we can use this same one that we had before, which is the 8 over sine 48. We'll do that for both of these. And then we're looking for not C1, but B1. And in this case, it'll be the B angle measures 98 degrees. And over here, it's 82 degrees, approximately. So B1 is going to equal 8 times the sine of 98 divided by the sine of 48. And then B2 is going to be 8 times the sine of 82 divided by the sine of 48. Okay, so we got it all set up here. Now we just need to throw it in the calculator and be done with this one. So we've got, well, let's go ahead and copy what we had up here. We don't have to redo. No sense recreating the wheel here. Okay, so we got 8 times the sine of whatever that 98 number was. So we delete this one, and we'll go find that 98. It's right up here. Over the sine of 48. Are we getting cut off here? No, that's okay. And so we get about 10.66, okay, so 10.667. And then the other one, type that in as well. Except instead of this 98 degrees, we're going to use the 82 degrees number. So let's see if we can find that. 82 degrees, where is it? There it is. Okay, so same. Wow. Okay. That was unexpected. How can that be? That can't be. What did I miss here? And this one has to be longer. Oh, no, wait. Shorter? What's going on with my diagrams here? Do I have these backwards? No, this is a... Oh, wait a minute. I think I mislabeled these. Yeah, I did. These are backwards. Okay, yeah, that's a problem. So we're gonna have to go back and fix this. I got the wrong angle measures here. Okay, so let's go back. We're probably gonna have to fix that last one too. So 8 is this sine. Wait a minute. Wow, what did I do here? I really messed this one up. Sorry, y'all. This should be 6 times the sine of 48. 6 over the sine of 48 equals B1 over the sine of 34. Yeah, geez, I just totally bungled this whole thing. I'm looking at this thing and something is not right here. And then this one should be 50. Okay, so let's try that again. And hopefully now, it really stood out to me, those should not be the same. Like this line could not be the same length as this line. So that's what, that's what kind of gave me cause for suspicion on that, whether or not I was doing this right, which obviously I was not. Okay, I think we got it fixed up here. Let's get rid of this. It's not going to be the 10.667. If it is, wow, that would be quite the coincidence, but I don't believe it's going to be. Okay, let's try this one more time. Okay, sorry about that. But in these videos, y'all know I don't edit these. If I make a mistake, I'm going to leave that in there. I think there's value in identifying your mistakes so you don't let them happen again. All right, let's try this again. Okay, so we got 6 times the sine of 34. So let's find that 34 degrees. If you just type in 34, you'll get a pretty reasonable estimate, but the decimal will be off. It won't be as good as if you use this longer form. So let's see if we can find it. There's the 34 right there. Okay, so this should be, Okay, so now we're getting something that's a little bit more reasonable here, 4.544. And then for B2, we'll do basically the same thing here, except we'll use the 50-degree angle measure. So where's that 50-degree angle measure? Right here. Okay. All right, so, okay, this looks a lot better. This one should be bigger than B1. 6.162, and I'm pretty satisfied with that. All right, well, there's number 8. I know this one kind of dragged on a little bit, but we're going to do number 9, and then we'll answer a couple of these logic problems and then be done. So number 9 will be pretty much the same as how we worked the other two. So let's jump into it. So we're going to start by figuring out how many triangles we have, although given the history with this assignment, it's probably going to be 2, but let's find out. Now we want to be even more careful with this one because the angle they give us is not labeled A. Okay, they gave us angle B. But we're going to work it out the same way. We just have to be careful about where we're plugging in everything. So here we'll have 11. Wait a minute. Sorry, no, not 11. We'll have 12. Already got kind of backwards here because we want to plug in the adjacent side. So not the one that's opposite, but the adjacent side. So 12 times the sine of 58, which is, let's find out. Gosh, how many times have we used the calculator today? Way too many, right? 10.176 rounds up to 177. All right, so we can see that in this case, we're not really comparing A because A is not the opposite side, B is this time. So since B is greater than the height, which it is barely, and B is going to be less than A, we're going to have 2 triangles. All right. So after we figure out that we have 2 triangles, we're going to sketch out our diagram, although I want to make sure that we label it correctly. So I'm just going to copy this so I don't have to redraw these triangles, because the setup should be the same. It's just a matter of making sure that we label the correct sides with what they are. We don't want to we don't want to do what we did on the last problem and get mixed up on the angle measures. Okay, so this angle measure is going to be 58, and this is going to be B. Usually we label that A, but it's all kind of arbitrary which one's which, but we want to label that bottom left corner with whatever the given angle is, which means that B11 is going to be the one that's opposite. So it's either going to be this one or it's going to be this one over here. So that is the opposite side in both cases. Now the adjacent side, which is going to be this A, is going to be 12. So 12 goes here, and it's going to be this side length in both cases. Okay? So when we go to label what we need, we're going to say, okay, well, this 58, this is our B, this is our A, so this is our A1 right here, that angle measure. Here's our A2. All right. Then the missing one is going to be angle C, which is up here. And side C, which is this little side here or this longer side here. Okay, so what we need to find is A and C and then side C. So we're probably going to copy this one since it's going to be more similar to what we've got. All right, so I'm just going to delete all this. This is all going to be different. All right, so we need to find, I'm going to change this B to A because that's the one we need instead of A, but the rest look like they should be okay. All right, so just to kind of talk through what we're going to do here, we're going to use the law of sines to find this missing angle and then subtract from 180 to find the other one. we're going to end up getting this A2 first. And then we'll use law of sines again, or no, before that we'll subtract all the interior angles from 180 to find the second angle, and then we'll use law of sines one more time for each of these side lengths. So let's first find this angle measure. Okay, so we'll use the pair that we know, which is going to be 11, make sure I get it right this time, over 58 equals 12 over sine of A. Okay, so we've got 11 times the 12 times the sine of 58 equals 11 times the sine of A. So sine of A is going to be 12 times the sine of 58 over 11. And so A, let's fix that. Get out of the way. There we go. A little toolbar gets in the way sometimes, I've noticed. So A equals the inverse sine of just exactly that, 12 sine 58 over 11. Okay, so let's go right straight back to the calculator. We've been there a while. See if I can find one of these inverse sines to duplicate. Inverse sine, there we go. And then, so what we have here is 12 times the sine of 58. Why didn't that? 12 times the sine of 58 over 11. All right, so we get approximately 68 degrees. All right, so that's going to be A2. And to get the obtuse one, we're going to subtract that from 180. Okay, so we get about 112. And then to find angle C, we're going to subtract each of these from 180 along with the other one, the 58. So we'll do 180 minus 58 minus, we'll start with the one we got first, is 68 degrees. So we get about 54. And for the other one, we have 180 minus 58 minus 112. And we get about 10 degrees. All right, so now let's go ahead and find the sides, which we will use the law of sines to do. Hopefully we don't mess this up like the last one. But in this case, we're trying to find C, not B. So we'll have the known pair, which is 11 over sine of 58. And then this side C should correspond to angle C, which in this case is 10 degrees, and in this case is 54. So C will equal 11 times the sine of 10 divided by the sine of 58, or it'll equal 11 times the sine of 54 divided by the sine of 58. So we'll just go ahead and type both of those in the calculator, and we'll be done with this one. Okay, so we got 11 times the sine of 10 degrees over the sine of 58. Okay, so this one's going to be about 2.183. And then we'll do the exact same thing, except instead of 10 degrees, we'll have the 54 degrees. And we get about 10.534 rounds up to 5. All right, well, there's number 9. Okay, so It's three examples of problems where you have two solutions. Remember, this is just happening in this one case, the angle side. The last kind of question that we're going to go over is this 10 through 12, where we're trying to figure out what are the values of t to make this have no solution. So let's talk about that. Okay, so for this last section, we need to determine what the side length for t needs to be in order for the triangle to have no solution. So if we go back to when we talked about the different cases here, you're going to have no solution when the opposite side is less than the height. So in this case, let's just type that here. So just, this is what we need to satisfy in order for there to be no solution. So in this case, in all these cases, they're giving us angle R, and they're giving us side R. So they're giving us the angle and the opposite side. This right here is the opposite side. And what we need to do is calculate the height and figure out, okay, well, based on that, what does t need to be? So for all of these, it will be true when the opposite side is less than the height. So let's write a little inequality here. So the opposite side here is 24. So that is going to need to be less than the height, and the way we calculate the height is we take the adjacent side and multiply it by sine of the angle measure. So the adjacent side here, so this is the opposite side, side opposite of the given angle. And over here, this is the adjacent side. Okay, so just as a little reminder, the height is equal to the sine, what happened there? Height is equal to the adjacent side there we go, times the sine of the given angle. Okay, so we want 24 to be less than the height. Okay, so we want 24 to be less than the adjacent side here, which is the t. Okay, that's what we're trying to actually solve for, times the sine of 30. Okay, now rearranging this, we're trying to solve for t, so we need to divide both sides by sine 30. So we have 24 over sine 30 is less than t. And if we're trying to isolate t here, so I'm going to move t to the left-hand side, say t is greater than 24 over sine 30. We're going to throw that in the calculator here and say that t must be greater than, where'd my calculator go? There we go. 24 over sine 30, which is 48. So t must be greater than 48 in order for there to be no solution. In other words, like this side length has to be so long, longer than 48, in order for this side r to be too short to complete the triangle. So that's going to be our solution, the values of t for which the triangle has no solution. And we'll solve all these very similarly. So in this case, we want 16 to be less than the height. I can spell there. Okay, so we have 16 is less than t times the sine of 45. So t needs to be greater than, well, I guess I'll just work it exactly like I worked the other one. 16 is divided by sine of 45 is needed to be less than t. So t is going to be greater than 16 over sine of 45. So t has got to be greater than, I don't think this is going to be rational. Yeah, sine of 45 is root 2 over 2, so we're going to have a decimal here. No big deal. All right, so we get about, so it's got to be greater than about 33.941. I was going a little too fast here and made an error when I typed in this expression. All the work is correct, but let me go ahead and type this in again. We should be getting 0.627. Now, if that angle measure is 60 degrees, this is 60, and we got 2 over here, we want to find what t has to be in order for there to be no solution. So, we're going to say that 2 must be less than the height. So 2 is going to be less than t times the sine of 60. Sine of 60 is going to be root 3 over 2, so we're going to get another irrational answer. The reason why we didn't get an irrational number over here is because sine of 30 is 1/2, and so it works out pretty nicely. So we've got 2 divided by the sine of 60 is less than t. So t is greater than 2 divided by sine 60. So t is going to need to be greater than 24, divided by the sine of 60. And so we get about 27.713. Somehow I made the exact same mistake on this one and the last one. I mean, I didn't make exactly the same mistake and I got a different number, but somehow I just did not type in the expression properly. I'm not sure what I was doing, or maybe I wasn't paying close enough attention. So let's go ahead and fix that. 2 divided by sine of 60. Looks like that gives us 2.309, not this 27 number. So let me go in and correct that so you guys can have the correct answer on there. 2.309. Yeah, that's it. So you guys have a great day, and I'll see you next time.